Hi friends, welcome to Studies with Joy. So, our today's topic is ninth standard Science 1, chapter number 4, Measurement of Matter. So, this topic comes in chemistry. Topic is of chemistry. So till then we have done the first three chapters of science 1, which were the topics of physics. First was laws of motion, second was work and energy, and third was current electricity. These were the topics for physics. But now we are going to do the fourth and fifth chapter in next lectures with chemistry. So these two chapters are of chemistry. So this chapter, measurement of matter, is mainly based on the basic chemistry that you will be needing in your whole year, ninth standard. And in every chapter, the concept of measurement of matter will be needed. So that's why this is the first part of chemistry that must be clear with you. So please don't skip this video, watch it full, or else it will be very difficult for you to understand it. I'm going to take very nice concept. It is very interesting. We are going to learn very many things, and I will just explain you once only that everything according to chemistry, everything is made up of atom. Okay, so atom is the tiniest particle of a substance. Okay, so before starting, please like and subscribe my channel, and also press the bell icon button so that you get the first notification when we upload a video, and also share the video with your friends. Okay, so let's start the topic. Now our first topic, before going to our first topic according to textbook, I will just tell you that what is atom. Atom is the tiniest particle of an substance. Okay, so then you have been heard about atom, and also atom consists of only one element. Okay, it compounds consist of more than one element, and mixtures have more than compounds elements. So their mixtures, compounds are different concept. We will learn about it. Now I'm just making you clear that atom is the tiniest particle of an substance. Okay, so now our first topic in this chapter comes law of chemical combination. So there is a law of chemical combination. So what is the law for chemical combination? Here in chemical combination, it is meaning for chemical reaction. There are two laws of chemical combination. We will learn about them also. But let's first let's understand what is law of chemical combination. Okay. First point, the composition of a substance changes during a chemical change. So, the composition means the property of a substance or a design of a composition or its physical form changes during a chemical change. Okay, there are two types of change, physical change and chemical change. So physical change, only the physical properties change, but in chemical change the composition, the properties also change of a substance during a chemical change. Remember it. Let's see more point. The fundamental experiments in this regard were performed by scientists in the 18th and 19th century. So the scientists had made some fundamental experiments in this regard to know more about it. So in the when it was performed in 18th and 19th century, while doing this, they measured accurately the substances used and formed and discovered the laws of chemical combination. So they, while doing the experiments in fundamental experiments, they found the accurate, they measured it accurately and the substance used and formed. Okay, two substances are formed during a chemical change. So scientists could then write the molecular formula of various compounds on the basis of Dalton's atomic theory and the laws of chemical combination. Here we shall verify it. We shall verify the laws of chemical combination by means of molecular formula. So we have to verify the laws of chemical combination using a molecular formula, and the scientists have could then write the molecular formula of various compounds on the basis of Dalton's atomic theory. So the Dalton's atomic theory, you would be knowing about Dalton in lower standards. We have learned about it, that Dalton had done an atomic theory about a gold thing that you would know. So this was the law of chemical combination. What? Let's see a image and understand it more better. Okay, so let's see about it. Let's see about it. There is an image I have shown. So let's see what is written in that. It is there that there are two flasks. Okay, there were two flasks, and in that one there is one test tube in both. In one of the flask and test tube, there is filled calcium chloride in the flask, but in the test tube it is filled with sodium sulfate. Okay, and let's see if we mix it. We are mixing both. See, in the test tube there is CaCl2, and in the flask there is different element, that is Na2SO4 solution. So there are two different solutions, and now we are shaking it and mixing them. First it was the what is the mass, that the first in the first experiment, that is 300.22 gram. Now while now we will mix it, then let's see what is the mass of it. Then also it is the same 300.23 gram. So this is the law of chemical combination. So this was the verification of it. See, before the chemical change, the mass is the same, and after the chemical change also the mass is the same. And this takes us to the law of conservation of matter. So now we are going to learn about the two laws of chemical combination. They are as law of conservation of matter and law of constant proportion. Let's see about law of conservation of matter. So let's see what is law. In the last activity, the mass of the original matter and the mass of the matter newly formed as a result of the chemical change are equal. So in the last activity, we saw that the mass of the original matter and the mass of the matter newly formed, the matter which was formed newly, were equal even after as a result of the chemical change. In 1785, the French scientist Antoine Lavoisier inferred from his research that there is no rise or drop in the mass of the matter during a chemical reaction. So in 1785, French scientist named Antoine Lavoisier inferred that there is no change in the mass of one reactants or products. There is no rising of mass or dropping in the mass of the matter during a chemical change or reaction. Okay, in a chemical reaction, the total mass of the reactants is same as the total mass of the products formed due to the chemical reactions, and this is called the law of conservation of matter. So it is telling, Antoine Lavoisier told us that the reactants यानी कि जो रिएक्ट कर रहे हैं एंड प्रोडक्ट जो हमें रिएक्ट या रिएक्शन करने के बाद जो मिलता है वो उन दोनों का ही मास सेम है. In a chemical reaction, the total mass of the reactants and the total mass of the products formed due to the chemical reactions, and this is the same, and this is called the law of conservation of matter. So now you understood what is law of conservation of matter. So now let's go to next law. I have given a diagram of it. It's the same but different it is. Now next is law of constant proportion. In let's see what is law of constant proportion. In 1794, the French scientist J. L. Proust stated the law of constant proportion as the proportion by mass of the constituent elements is the different samples of a compound is fixed. I will repeat, the proportion by mass of the constituent elements in the different in samples of a compound is fixed. So, this in 1794, a French scientist named J. L. Proust stated the law of constant proportion, that the proportion of the mass of the constituent elements, there are some elements and उनका mass है, उनका proportion, उनके mass का जो proportion होगा, you will be knowing about ratio and proportion, so that the proportion of the mass of the constituent elements in the different samples of a compound is fixed. So different samples कंपाउंड्स के कुछ दो सैंपल्स है, दो डिफरेंट सैंपल्स है, उन दोनों का मास का प्रपोर्शन फिक्स्ड होता है. लेट्स सी बाय एन example, the proportion by mass of hydrogen and oxygen in water is obtained from any source 1:8. So water molecular formula is H2O. So H2O में दो constituent elements कौन से हैं? हाइड्रोजन और ऑक्सीजन. देयर आर द टू कॉन्स्टिट्यूएंट एलिमेंट्स. सो उन दोनों का जो प्रपोर्शन, their proportion is the same in any samples of it. Okay, it is telling us the proportion of their mass is the same and in any sample of water. You can see it, and that is the 1:8, the proportion of water of mass, proportion by mass of hydrogen and oxygen in water is obtained from many sources is only 1:8. I will explain you afterwards that how it came 1:8. Next point. Similarly, the proportion by mass of carbon and oxygen in carbon dioxide obtained from any source is 3:8. One more example is of carbon dioxide. So the proportion of mass of oxygen and carbon are the two components of the carbon dioxide. So their proportion is the same. That is, if we get from any source carbon dioxide, the proportion of the mass will be 3:8 only. It is not telling it that its mass will be the same. It is telling us their proportion will be same. Okay. One more I will tell you. This means that in 44 gram of carbon dioxide, there is 12 gram of carbon and 32 gram of oxygen. So that the proportion by mass of carbon and oxygen is 3:8. So in 44 gram, there will be 12 gram of carbon and 32 gram of oxygen. Okay, so that the proportion becomes 3:8. Okay, because that we have to divide it. Now let's go on and learn about the atoms. Let's see a image for law of constant proportion. Law of constant proportion we have done, and now let's see about its image. And law of constant proportion is also telling about the ratios and proportion. Now I have given some proportions of some elements, and it is 14:16 because it is containing nitrogen and oxygen, and that is final ratio is 1:1. In that way I have given many others. Now let's see next image. Does law of constant proportion work on burning wood? So I thought that this question will be in your mind, so let's verify it, that does law of constant proportion work on burning wood? So according to law of conservation of matter, that the reactants and the product's mass is the same. Is it working on this burning wood? Yes, But why don't we get the same mass of ashes? The answer for that is that if we also take that the air which is released during burning, and if we check its mass also, we contain that also, then the mass will be same. We will not get all the mass same just by its ashes. Okay, the gases all should be considered, and law of constant proportion also work on it. Okay, this was a question. Now next topic will be atomic size. Now we will learn about atomic size. What is atomic size? Let's see. But first, I will just tell you that everyone knows that an atom consists of three main constituents, which are the protons, the neutrons, and the electrons. And the protons are positively charged, electrons are negatively charged, and neutrons are neutral in nature. Okay? So they have no charge. So this was the main base that I made you clear. And also that protons are denoted by P, electrons by small e, and neutrons by small n. Okay, now let's see about atomic size. What is atomic size? At the center of an atom is the nucleus, and that they are moving electrons in the extranuclear part. So this sentence is telling us the position of the neutrons, electrons, and protons. So neutrons or protons are inside the nucleus of an atom, and there are orbits around the nucleus. So around the atom, that are called, that orbits are called, or that space is called the extranuclear part, because it is not inside, it is outside. They are mainly, it can be 3 orbits or 4 orbits, mostly they are. The electrons are negatively charged elementary particles, while the elementary particles that make up the nucleus are positively charged protons and electrically neutral neutrons. So electrons are negatively charged, that I told you, and there these electrons are revolving around the nucleus in the orbits which are present in the extranuclear part. Okay, so these electrons are where they are in the orbits and revolving around the nucleus of the atom. It's just like the planets are revolving around the sun. It's like that only. Okay, so this was the main basic that I told. Now let's see what is the atomic size. The size of an atom is determined by its radius. The atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in nanometers. So what is atomic size of an atom is determined by its radius. So as we know that what is radius in the atom? Radius, that is the radius is from the nucleus to the last outermost orbit, last orbit of the atom. There can be, the last would be 3 orbits, there can be any number of orbits, but the last one and the from the nucleus to the last one, what is the radius of that atom or that circle which is be formed, is the atomic size of the atom, is that much bigger is the atom. Okay, and the atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in which, what is the unit? Nanometers. I will just give you one. 1 upon 10 raised to 9 meter is equals to 1 nanometer. Remember it. And 1 meter is equals to 10 raised to 9 nanometer. Remember this. Okay. Now let's see more about atomic size. Let's see while seeing a image. I've just shown you the image. So in this way, that blue color dots are the electrons and the yellow color is the nucleus where are the protons and neutrons. So that black arrow is showing the atomic size, that from the nucleus to the outermost orbit of the atom is the atomic size. Next question comes that if the outer number of outermost orbit is the same for two atoms, then how we will get the size of the atom? Means I will tell you, first we would see the outermost orbit, how many orbits are there. If there are 4 orbits, then the atomic size will be greater. Let's consider two atoms. The one of the atoms is having 4 orbits and second atom is having the 3 orbits. So usual it is that the atom having 4 orbits will have the greater size and the atom having 3 orbits will be lesser. So how we will get to know the number of orbits? जितने भी numbers of orbits होंगे उतना ज़्यादा उसका size होगा. Okay, so that way we got to know. But if there are the same number of orbits in two atoms, then how we will know which is the bigger one and which is the smaller one? Example, that magnesium and sodium are having the same number of orbits. So now how we will know that which one is bigger and what's the atomic size of both? The atomic size depends on the number of electron orbits in the atom that we saw. Next is, the greater the number of orbits, the larger the size. Then this we learned. For example, an atom of potassium is bigger than an atom of sodium because of the number of orbits. This was the example for that. If two atoms have the same outermost orbit, then the atom having the larger number of electrons in the outermost orbit is smaller than one having fewer electrons in the same outermost orbit. For example, an atom of magnesium is smaller than an atom of sodium. So if the number of orbits are the same, then we will consider the number of electrons in the last orbit. If the number of electrons are more in the last orbit, then its size will be lesser than that atom in which the number of electrons are less than in the outermost orbit. For example, magnesium is smaller than the atom of sodium. Why? Because their number of orbits are same, but magnesium is having more number of electrons in its outermost orbit, and sodium is having comparatively less number of electrons in its outermost shell. That's why the magnesium is smaller. अब स्मॉलर क्यों ज़्यादा है इलेक्ट्रॉन्स फिर भी? क्योंकि उन्हें सिकुड़ सुट के रहना पड़ेगा, बिकॉज दे हैव टू बी वेरी क्लोजर टू ईच अदर, दैट्स व्हाई दे हैव टू बी वेरी स्क्वीज्ड. और सोडियम के पास कम है, इसलिए उसको एकदम फ्री होंगे उसके इलेक्ट्रॉन्स, ज़्यादा घूम सकते हैं, उनको एक से सिकुड़ के नहीं रहना होगा. दैट्स वाई the orbit having more electrons is smaller than the orbit having less electrons. Okay, next let's go to the next topic, that is atomic number. Before going to it, let's see a diagram of that I told you. Now let's go to next topic, atomic number. So what is atomic number? Let's see. The number of protons in the nucleus of an atom is the atomic number of the atom. So the number of protons, न्यूक्लियस में प्रोटॉन्स और न्यूट्रॉन्स होते हैं, उन्हें साथ में बोलते हैं न्यूक्लियॉन्स. सो उनमें से न्यूट्रॉन्स तो ये होते हैं चार्जलेस, लेकिन जितने भी नंबर ऑफ प्रोटॉन्स होते हैं न्यूक्लियस में, उसे हम लोग उस एटम का एटॉमिक नंबर बोल देते हैं. ओके, atomic number is denoted by capital A. The number of protons and electrons in an atom is the same. So in an atom, the number of protons and electrons is the same. That's the rule, and that you have to remember that अगर उसका एटॉमिक नंबर 8 है तो उसका उसका मतलब है कि उसका प्रोटॉन्स का नंबर 8 होगा और इलेक्ट्रॉन्स भी 8 ही होंगे. That is very much asked in the examinations. It is very confusing. So remember the number of protons and electrons in an atom is the same. So atomic number of an atom is the number of electrons and number of protons in the atom. So what is the atomic number of an atom? Is the number of electrons and the number of protons in an atom. Okay. So this, and next, for example, the atomic number of oxygen is 8, so the number of protons and electrons present in it is 8. But why we are not considering this as 16, the atomic number? We are only considering the number of protons because the opposite charges are there. Okay. So this was the atomic number concept. I will just give you the atomic number of some elements which are commonly asked. See, I have given some elements atomic number. Let's see. Hydrogen atomic number is 1, and helium atomic number 2, carbon atomic number 6. And I want to tell you one important thing, that hydrogen is having only one electron and one proton as per the atomic number. So that is a very much asked question. And why it is having only one? According to the law of duplet and octet, there is applicable law of duplet is applicable on helium and hydrogen, and law of octet is applicable on other. So law of duplet tells us that there should be at least 2 electrons in its outermost orbit to the atom be stable, and law of octet tells us that there should be 8 electrons in an outermost orbit of an atom for the atom to be stable. So this was the atomic numbers of some elements. Now let's go on with atomic mass concept. What is atomic mass? The mass of an atom is concentrated in its nucleus, and it is due to the protons p and neutrons n in it. The total number of protons and neutrons in the atomic nucleus is called the atomic mass number. Protons and neutrons are together called nucleons. So what is the mass of an atom? In atomic number, only protons are the number of protons are considered. But in the mass of an atom, the number of protons plus the number of neutrons is the atomic mass of the atom. Okay. So what is the mass of an atom? You have to plus the number of protons and the number of neutrons. It is not necessary that the number of protons and the number of neutrons are the same. Okay. Protons and neutrons are together called nucleons. An atom is very tiny. Then how do we determine its mass? Scientists too faced this question. It was not possible for scientists of the 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. A reference atom was required for expressing the relative mass of an atom. The hydrogen atom, being the lightest, was initially chosen as the reference atom. The relative mass of a hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms become available to other atomic mass number, that is P plus N. So, what happened in the 19th century? How do we mass? हम लोग एटम को हाथ में तो पकड़ के उसका मास तो कर नहीं सकते, वो इट इज़ वेरी वेरी टाइनी. तो हम लोग कैसे उसका मास निकाले? वो बहुत मुश्किल था 19th सेंचुरी के साइंटिस्ट के लिए. तो अभी तो हम लोग कर सकते हैं, हम लोग के पास बहुत सारे डिवाइसेस आ चुके हैं ये सेंचुरी में, लेकिन हम लोग किस तरह करें? उन साइंटिस्ट को उस टाइम पे बहुत प्रॉब्लम हो रहा था, इसलिए उन्होंने रिलेटिव मास ऑफ एन एटम का कॉन्सेप्ट निकाला. सो रिलेटिव मास मतलब हम लोग किसी एक को ऐसे नॉर्मल ले लेंगे. जब एज यू गो इन मार्केट देयर इज वहाँ पर भी वजन करने के टाइम पे 2 kg को ऐसे रिलेटिव रखते हैं और उसके हिसाब से वजन करते हैं. वैसे ही हमने भी साइंटिस्ट ने भी ऐसे ही किया कि उन्होंने एक रिलेटिव मास लिया. दैट रिलेटिव मास ऑफ was the hydrogen atom, being the lightest, was initially chosen as the reference atom. So the relative mass of hydrogen was accepted as 1 because hydrogen has 1 electron and 1 proton. Therefore, the magnitude of the relative atomic mass of various atoms become available. So हम लोग को दूसरे atoms का मिल जाता है relate मास इस हाइड्रोजन के साथ कंपेयर करके हमको मिल जाता है. So that is the relative mass. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12 into 1 upon 12. That is 1. So the mass of one proton and one neutron on the scale of relative atomic masses is approximately 1. Okay. Next, I will just give you some of the atom marks that are a table of which are most important, and also it is mentioned in your textbook. In some blanks I have filled it. Element hydrogen atomic mass is 1, helium 2, lithium 7, beryllium 9, boron 11, carbon 12. If you don't remember the atomic number and you remember the atomic mass, then you can get the atomic number, but not this trick doesn't works in all tricks. You can just divide the number by 2. If the atomic mass of boron is 11, if we divide it by 2, it will come as 5.5, but we cannot consider the point decimal, so we will consider it as 5. Okay, so this I am ending this lecture here only. Please like and subscribe. We will continue in next lecture with this chapter.